Hey Algebra 1 students, today we're going to talk about Chapter 1, Variables and Expressions, and we're going to focus today on Sections 1, 2, Order of Operations. Today we only have two vocabulary words, that's to evaluate and order of operations, so you don't have to use a whole lot of space for your vocabulary. Let's take a look at each word. Okay, so to evaluate really just means to find the numerical value of a particular expression. So if you had something like 3 plus 2, I could ask you to evaluate that and you know the answer is 5. Or I could tell you that A is equal to 2 and B is equal to 7. Can you evaluate 2A plus 3B? So again, I want the numerical value of this expression. Simply put, I would substitute. I'd do 2 times 2 plus 3 times 7. Obviously, we'll talk about order of operations, but I got to do my multiplication first, if you remember order of operations before. And then I'm going to add 21, and my answer is 25. So to evaluate simply means to give a numerical value for an expression. So order of operations. We recognized this before. We've heard PEMDAS. Please excuse my dear Aunt Sally. What this mnemonic device, I'll write it down, P, E, M, D, and AS. What this gives us is the way or the rule with which we can figure out what operation to perform first when we are identifying or when we are working with evaluating an expression. So we know that this refers to parentheses. This refers to an exponent. This is multiplication and division. Multiplication and division in this case are equal. So what we do is we just go from left to right in our problem and whenever we're working on a problem. And addition and subtraction are also equivalent. And what that means is if I have a problem where there's just addition and subtraction, I just go from left to right. And we'll do a few examples in a moment. So our first example is to evaluate some expressions. All 4 of these expressions really deal with exponents, so this is kind of a really good review for exponents. So this first one, part A, says 3 to the 5th power. That means 3 times 3 times 3 times 3 times 3. I'm multiplying 3 5 times. And though it'll take a little bit of work, we can do this. 3 times 3 is 9 times it. So these guys give me 9, these guys give me 9, and this is just 3. So now I'm multiplying 9 times 3, 9 times 9 times 3, which ultimately gives me 81 times 3, which is 243. If you got that, you should be really proud. This next guy, very similar. We're just going to multiply 2 to itself 4 times. So when I raise 2 to the 4th power, I think everybody can do this, you get 16. 7 to the 3rd power would be 7 times 7 times 7. 7 to the 3rd power is 343. This number is a palindrome because it reads the same back and forth. Not a vocabulary word, but just a word that comes up from time to time. So this will be a palindrome. You can read it the same way either way. So 7 to the 3rd power is 343. Finally, 4 to the 5th power, which we could expect is 4 times 4 times 4 times 4. Hopefully I said that 5 times, but I wrote it 5 times. Is 1,024, and that's if I multiply it all together. One quick question, do you have to write out 3 times 3 times 3 and 2 times 2 times 2? Not really. Not unless you, if you can do it very quickly, you don't have to take the time to do that at all. If it's like 7 squared and you get 49, cool. But if you're not sure, then I would say write it out. Reiterate what exactly that exponent refers to. Let's move on to the second example. So this second example, we're using order of operations. I'd like you to check out the little, putting the mnemonic device right here really helps me out when I need it. You know, if I have to use it, I'm going to go ahead and just refer to this side. So let's look at this first example. I'm going to rewrite it the way the text has it. 16 minus 8 divided by 2 to the 2nd power plus 14. And so the first thing I'm going to say is, are there any parentheses? Is there a pair of parentheses here? No, there's not. So I don't have to worry about that. I've already done P. P's done. Exponents. Yes, there is one exponent, and it is relating directly to this 2 here. So I'm going to deal with that. Look at how I rewrite the problem. Everything is exactly the same, except I now substitute. Instead of 2 squared, I'm going to substitute in 4. and I've got 14. Next, I'm going to see what else I have. No more exponents, so I'm done with that. Multiplication and division goes from left to right. I do have division, so that supersedes everything else here. So this becomes 16 minus 2. Where did the 2 come from? Well, I took 8 and divided it by 4. Got 2, and then now I have 14. And so the next thing is addition and subtraction. When I was a kid, I would do 2 plus 14 first because I thought addition came first, but it does not. Addition and subtraction are equivalent. We just go from left to right. So from left to right, we get 16 minus 2, which gives me 14. Then I'm going to add another 14 to it, and I get 28. 28 is my final answer. In part B of example 2, this looks a little weird. This font is kind of crazy. I think I won't use it again. But this is 3 plus 42 times 2 minus 5. This 42 looks like 4 to the second power, but it's not. So now that we know that it's 42, let's take a look. First thing we need to do is multiplication. Multiplication supersedes everything that is here. There are no parentheses. There is no exponent. Multiplication is the next thing. So I'm going to do 42 times 2, and I'm going to get the first part of my answer. So 3 plus 42 times 2 is 84, and then I'm going to subtract 5. The next thing that I have is addition and subtraction, and that's equivalent, so it goes from left to right. I'm going to add 3 to 84. That's going to give me 87. Then I'm going to subtract 2, and my final answer is 82. The final part of example 2 is this guy. Subtract 20 minus 7 plus 8 squared minus 7 times 11. So I'm going to just draw a little arrow here to give myself a little bit more space. If I were to work on this problem, again, I'm looking for parentheses. There are none. Is there an exponent? Indeed there is. That's associated with the 8. So I have 20 minus 7 plus 8 squared. I'm going to replace that with 64 because that is what 8 squared is. That is 8 times 8 minus 7 times, use a dot there, times 11. So the next thing I need to do, I've done parentheses. There were none. Exponents handled. Multiplication and division is next. I've got to do my 7 times 11. So my problem reads 20 minus 7 plus 64 minus 77. So I replace 7 times 11 with 77. Finally, I can go from left to right, adding and subtracting as I please. Well, not as I please, from left to right. And when I do that, I get, 20 minus 7 is 13. 13 plus 64 is 13 plus 64 is 77. And then 77 minus 77 brings me to 0. So my answer here is 0. You can check my math. Tell me if I'm wrong tomorrow. And that's it for this example. Let's move on. Example 3 has 3 distinct parts. This is really supposed to read 2 to the third power minus 5. All of that over 15 plus 9. But what I'm going to do is I'm going to take each one separately so we don't have to kind of crowd all the information on one sheet. So let's take a look. All right, so again, I wrote down my order of operation mnemonic device over here, and I'm going to use that to help me through this problem. I need to do what's in parentheses first. So my rewrite looks like this. 4 divided by 2 plus 5 times the quantity of what? Times the quantity of 4, because that's what 10 minus 6 is. So I've handled the parentheses. Now I need to deal with the exponents. There are none, so I'm going to say that's done as well. The next thing I'm going to do is multiplication and division. I'm going to go from left to right. Recall that this here, my friends, my little chablitos, that is multiplication. So we've got division here and multiplication. We'll save that addition for last. So I'm going to just go again from left to right doing what I need to do. 4 divided by 2 is 2 plus 5 times 4 is 20. So obviously you guys can see the last step is to add or subtract, and we've got addition, and our final answer is 22. Not that bad. I am enjoying writing PEMDAS on each paper, for each example, but this does not mean you need to write it over and over again. It really is just a guide, so don't worry about that. Do write down the example, copy the problem, and make sure you copy the work that we're doing for it. So again, we've got 2 grouping symbols here. We didn't really talk about brackets, but we're going to treat brackets like parentheses. So this 6 is on the outside, but everything here needs to be done first. So this basically says 6. I like rewriting it so you can kind of see. This font is funky. So 32 minus the quantity of 2 plus 3 all of that to the second power. So what this means is I'm going to do what's in the brackets first. I'm going to ignore the 6 for a little while. And when I get inside the brackets, I see I've got parentheses. So I'm going to deal with that first. I'm bringing the 6 down. I'm bringing everything down just to see that nothing else is changing except 2 plus 3 is going to become 5. And that's to the second power. And again, I'm still working within the bracket. Still working within the bracket, I've got to do the exponents within the bracket. So 6 times 32 minus 5 to the second power is 25. That's 5 times 5. Now I'm going to do subtraction. Somebody out there is saying, but wait, you said multiplication gets done before subtraction. You're a crazy woman. Indeed I am, but this time I'm actually writing what I'm doing. Here's why. Because it is within the bracket, I still have to honor the bracket as a type of parentheses. I got to do that first. So I have to do 32 minus 25 before I multiply this thing by 6. And yes, there is an understood multiplication all throughout. So 32 minus 25 is 7, and my problem now looks like this: 6 times 7, and everyone is cheering because you know the answer to be 42. Great. Friends, we are almost there. This is the last example, and I know you're cheering, or at least I think it is. It might be. We'll see in a minute. I think this is the last example. So take a look. We've got 2 to the third power minus 5, all of that being divided by 15 plus 9. I'm going to write that again because it just looks kind of crazy. So rewritten, it looks like this: 15 plus 9. And we talked about this being this division sign. If we didn't, then I'm talking about it now. This division sign is really a type of a grouping symbol. It tells me do all this junk first, then do this. And then you know what that means: divide. So when I see that grouping symbol, I can actually do this, right? It is 2 to the third power minus 5 in parentheses divided by 15 plus 9. All right, so again, I'm going to do what's in the parentheses first. The division is going to have to wait. 2 to the third power is 8 because exponents supersede subtraction, division, everything else. So 2 to the third power is 8 minus 5, right? Divide that by 15 plus 9 is what, my little friends? Yes, yes, indeed. It is 24. And then continuing on, 8 minus 5 is going to give me 3, so I end up with 3 divided by 24, which I can then write in the handy fraction form, 3 over 24. Anybody can reduce it? Do it? Do it? Yes, 1/8 is my final answer. Yay! All right, good friends, so we've reached the end of this lesson, and your assignment is as follows. Please take heed of all the problems. I know it looks like a lot, but I think it's like 23 or 24 problems, not major. I think you can handle it. Do the best you can, and we'll talk about this lesson and anything else on your mind tomorrow. Have a great one.